Good morning, everyone. So it's a great pleasure for us to see all of you in this gathering. So this is our first distinguished lecture of the year of this series. This is the fifth series of having similar event in OUSL, and this is organized by International Relations Unit in association with SETME and IT Unit. In this event, we are in collaboration with Civil Engineering Department. So let me formally welcome our distinguished lecturer today, Professor Priyan Mendis. He's senior professor from Melbourne University, and today topic is high-rise building. So they are the vast experience he has in the worldwide. So he will be sharing all. Apart from that, actually our audience is also a very prominent audience we have today. From when I start from Engineer Shiromal Pranandu. Engineer Shiromal Pranandu is the session chair of the today event, and he's the managing director of principal and the structural engineer, director and manager of the other from his institute is also welcome. Actually, if I just tell about Shiromal is the one of the pioneer structural engineers in Sri Lanka who involved most of the high-rise building in Sri Lanka, including Lotus Tower. Then let me welcome Captain, actually Maga Captain, everyone used to use it, Mr. M.G. Koratna, Chairman of Maga Engineering. So it is a privilege, very high privilege, for us to just to sit in the audience and be in participating for this event. Then Mr. Ravi Nistanka from Millennium Concrete Institute. Actually, he's the pioneer chemical supplier for all in concrete industry. So if I continue, Mr. Sanka Seniratna, I think he's on the way from INSI Cement, and all his managers from INSI Cement as the main supplier of the material supply in country. And there should be, actually we have invited two Chinese managers. I think they didn't come, so anyway I just mentioned. Then Professor Ruan Veerasekara from Moratu University, thank you very much for being with us. And Mr. Sunil Shanta, project manager, Port City project. Yeah, he also, yeah. Apart from that, actually internally also we have a lot of assets. May I start from our Vice Chancellor. He's been with us with his busy schedule. Thank you very much, sir, for being with us. Then Dean Faculty of Engineering is with us. And not only that, actually, Chair of the Civil Engineering, Professor Veerasekara, and ISL President is our department professor, so it is a great privilege. Thank you so all for being with us. So apart from that, all other professors from the university, all other lecturers from the university, technical staff, and we have few students in the audience as well. So I think I should beg your pardon, because all these arrangement and everything made for us to go live and video things and all other, because of that why this is very congested and look like in this arrangement. So with that, so my next duty is to introduce Professor Priyan. Let me introduce him formally. So Professor Priyan is a professor in the Department of Infrastructure Engineering and the leader of the Advanced Protective Technology of Engineering Structure group at the University of Melbourne. University of Melbourne is the one of the number one ranked university in Australia. He is also the director of the Australian Research Council Centre for Prefabricated Construction. Professor Mendis obtained his BSc from University of Moratuwa and PhD from Monash University, Australia. He worked as a structural engineer for 5 years at the Cornell Wagner Limited, Australia's largest structural engineering company, before joining the university in 1990. He has been involved in design of many landmark high-rise structures in the world, including the world's tallest building, Burj Khalifa, and Australia's tallest building, Eureka Tower. He has also made a significant contribution to the design of high-rise structures in Sri Lanka, including Lotus Tower. Research interests include design of tall buildings and bridges, protective technology of structures, smart infrastructure design, assessment and monitoring, high-strength, high-performance concrete, seismic design of reinforced and pre-stretched concrete structures, disaster mitigation and management, sustainable infrastructure. He is also a chartered engineer and fellow of Institute of Engineers Australia. Last year, he was awarded the Honorary Lifetime Membership, the highest award, of Concrete Institute of Australia for outstanding contribution to the concrete industry. Tall buildings are becoming very popular in every city around the world. In Sri Lanka also has seen boom in high-rise construction. Professor Mendis will be speaking on the world scene last trends in design and construction of high-rise structures from his experience last 30 years working in this area and his latest research and development work with you. Actually, apart from all these, what we have, I have read you in general. He has involvement in world tallest building up to some level, and Malaysia tallest building, previous tallest building, and Eureka Tower in Australia, and 1 kilometer tower in Dubai. If you take in Sri Lanka, I think more than 60 or the 80% high-rise buildings, there should be some involvement with either Professor Mendis or with Shiroma. It should be, including Lotus Tower, Altair, Colombo City Centre, you name it, he should be around there. So may I invite Professor Priyan for you to give the distinguished lecture.
Thank you very much, and thank you very much, Tushara, for that very kind introduction. And so I don't have to take too much time introducing myself, but I'm actually, in fact, it's more for celebration as well of, it's about 30 years, exactly 30 years to date that I've been involved in the first high-rise building as a junior structural engineer. So that's, I'm celebrating that, and that's my first involvement. And again, that other one I'm celebrating today is that again 25 years since that I did the first short course on tall buildings in Sri Lanka, and Mr. Shomal Fernando may remember that, and organized at Moroto University. I managed to do a 2-day short course, and so 25 years, I'm feeling a bit old now, but since that time, and although I live in Australia now more than 35 years, still my heart is here in Sri Lanka. And it's to be really, I feel honored to be here and giving this type of lecture. So always in Sri Lanka, I will do whatever I have to do. So, in fact, in this case, I had to really thank the Vice Chancellor and all the other staff at Open University of Sri Lanka inviting me to give this lecture. And I'm really honored to be and privileged to be in such an audience. I know it's a selected audience. Because of this setting, I know the numbers have to be limited. To who can be invited, the numbers have to be limited. So then I think it's really hand-picked type of audience was Tushara. You like now remember that you were telling me with Professor Kolita when you organized in this. So it's really, as I said, privileged to have the again, as I said, the Vice Chancellor, the leader of the engineering profession in Sri Lanka, presently the Institute of Engineers Sri Lanka president here, and senior professors like my good friend Ruwan Weerasekara, who was a president of the Structural Engineers Institute at some time, and also coming back to the lastly, I want to acknowledge the the people I would call the transform the industry in Sri Lanka. Why Sri Lanka is right at the top, where I have been some experience working in other countries, especially I was advisor to Vietnam government in high-rise. Construction minister himself invited me to be part of it, that group. And then also in Malaysia I've done. So few countries I've been involved with and used to go to Dubai a few times at that time. But all that, I could see multinationals have come and dominated the industry. But Sri Lanka is different because Sri Lanka is still dominated by these world-class design institutions to construction companies to also material suppliers. So I have actually, in fact, I had to personally acknowledge I would consider the people who transformed the industry in Sri Lanka. That is, I would say Captain Kuratna in the construction, building the tallest building in Sri Lanka, Celestia's Tower. I remember all these discussions in Melbourne, when interesting discussions. Mr. Shiromal Fernando who designed that building and at that time transformed the industry. People like Mr. Ravi Nishank, chemical admixtures, it's really multinational companies are dominating in other places, but he managed to really bring that chemical admixture industry and to a very high level. So as I said, rather than taking a lot of time, but I'm really and privileged to have the audience. Also, one of the I become emotional when I say that. Been an academic now for how many years? Been academic again. I had a part-time appointment as well with the industry and the academia. Well, Melbourne University at the beginning, they gave me a chance to still work in the industry, be academic as well. So like a transition period. That really helped me actually. That beginning, that practical experience really helped me there. So as an academic, I'm really very happy that there are a number of students also here and senior staff here, academics who have done a lot to really keep going. It's a dedication and to be academic, and so I had to really acknowledge that. Sorry, sometimes I become emotional when I say these things. But anyway, coming back to the presentation. And today, actually, in fact, within this short period, I selected some topics where I would say that where the world is heading, and then where we are, and so on, where we are, and for the future, how we can project ourselves to the future. To say that some key points. Before that, I had to really acknowledge Melbourne University because they have given me the chance to really do the world-class research. So, in fact, Melbourne University, as a snapshot, it's a #1 ranked university in Australia, founded in 1853, and 18 faculties and schools. We have 8,500 plus staff, 50,000 plus students, international students. It's in fact, I think I'm all right to say this, but we had to put a ceiling on the international students. We are getting too many international students now to Melbourne University, so we had to put a cap on some of the courses because we don't want, some of the courses are becoming really more international students than, including civil engineering. I have to say that we can get any number of students, China, and so we had to put some ceilings there to really to limit the international student numbers. So we are privileged to be there and getting all those rankings, and rankings are not the only thing, but that's really important. Now, getting back to the topic, the tall buildings are introducing new challenges which we didn't have so many years back when I started my career. Recent trends towards the slender, flexible, and lightweight buildings. I gave a talk in Shanghai about 2 years back. So some of the Chinese writing is because from that, but also actually, but personally, I had the apologies from the two Chinese company leaders who were invited today, but that because they are heavily involved with things today, but they apologize. But anyway, I kept the Chinese writing there. So, and also because it's going to the YouTube, I'm finding that most popular, if you put something in the YouTube, China will just next day, you will see 100,000 hits. That's the kind of attention that from there. So I kept the Chinese writing there. I didn't translate that. One of my very good PhD students translate all this, put the words. So that's the first one is this. So this is a challenge for everyone. Just the designers, a challenge for the designers, challenge for the construction people, challenge for the researchers like us, R&D side, there are challenges because it's really new challenges. And the key towards I will bring some of those points during the presentation. And then the other one, which is making it difficult, is that those days when we started high-rise, it's a residential building. We knew that it's office building. So it was easy to start with. Now the problem, designers as well as the construction side, the problem is that it starts with a residential. It's a mixed development. So you can have residential, part of the offices, part of the hotels, all that. It makes it difficult. Fit outs are difficult even from the beginning. And even the simple things like live loads. What do you use live loads? It's different in a live loads in today. I'm not going to use too many technical terms, but some of this, the imposed loads, the moving loads, people and so on, different in residential to office. So where do you start? Then halfway is happening in Australia. I know that that's why people like us sometimes get we have to advise the designers and builders. But it's really they start like a design with a residential building, then they want to convert into halfway to office building. The live loads we are designing for about 2 kPa for residential or 1.5 to 2, and then get into office, 4 kPa or whatever. Then what do you do now? Because it's halfway constructed. So this is the kind of challenge that together we will have in the future. How to provide that flexibility. Then they will come and say, we want to add a few more stories. We want to have the tallest building. Actually, this is true what I'm going to say. They're still talking about, there's a bit of competition in Malaysia. Petronas Tower, I'm also involved at the beginning, another building is going to be taller than Petronas, been built at the moment. So Petronas people started asking question, can we put more stories? Can we become the tallest in Malaysia? So like that, so this is a bit of a challenge for us. Again, I don't want to spend all the time, but I'll be really brief on some of these comments I'm going to make. And again, the epicenter is moving, where the super tall buildings were in North America and so on before. Now it's more in the Asian region. It's really opportunity. Sri Lanka, we were told, in Dubai, Mr. Jamal also was there when we attended the tall building conference, and we were told that Sri Lanka is one of the most active places for tall buildings. So we had to be very proud of it. And so epicenter is changing, and by the region. Again, as a usage, of course, I mentioned that. We're moving towards more of the mixed used. We can't ask the client. Maybe we have to ask the client, what do you want to do? But then he will change his mind halfway. So anyway, the shapes and all that. World's tallest building, the Burj Khalifa. Again, I will show my involvement with that. And then the Shanghai Tower, and you can see the shapes are changing. And it's always shapes are changing and so on. See the shapes. So we are the main task for the architects is the first is to say we want to have a building which is not been built anywhere. We have to be different. So you can see the shapes have changed as well. All this is important, where it's heading now. Those days, again, my first experience also designer, again, early 90s, 200-meter building. I was, as a junior engineer, I was even the project engineer for the site, also in charge of the core. But early 90s, that was a 200-meter building. But see now, the trend is 300 meters is really like the norm. People will be asking the question now, tall buildings. Clients will be everywhere. They'll be asking the question, why not tall? Those days, the question was, why designing a tall building? It's the other way around now. The clients are saying, I want the tallest building which can be built, because there are numbers. These are business business decisions. We know that we are running out of space, we are running out of land is really obviously getting more and more expensive. So best way is to really go higher and higher. So so it's not the others, designers asking the question, can we build a tall building? But now the clients are saying we want to have the highest, because that's again, sorry to repeat, but it's a business decision, because going taller is the best option, and your return is a lot higher when you go taller. So Colombo, Sri Lanka, see as I said, the skyline has changed so much last so many years, and and then we have a huge opportunity here. Port City will be built, and there will be many high-rise coming up. So it's an exciting time for the high-rise designers to the builders. As I said, the students who are working high-rise. In fact, again, I started the high-rise structures course. It's probably one of the first in the world. This is a long time, mid-90s. As a junior lecturer, I started the high-rise structures course. It's still running, and the thing is, it's a special art. It's not really going and learning concrete design or something. It's very important. But high-rise is again for the students and engineers around the world. It's a specialist area. So no one can say that if you have not done a design of a tall building, if you're not done construction of a tall building, if you're not supplied materials to the tall buildings, you can't be involved. You need that experience. It's a specialist area. There are problems. I can't name. I had a call 2-3 days back. I will ask you to look at the web and you will find it. There was a problem in a building in Sydney a few days back. Again, because it's in the web, I can't name, but I'll leave it as an exercise to find. All the building was evacuated because there was a failure. It's dangerous. It's really, if you don't do that, maybe I'll stop short saying why I was asked to be involved, but anyway, these are really very important for to figure out, and it's going to the courts, and it's big things happening there. But if you look at the Sydney high-rise failure of a building, you will see that. So that means it's showing that it's everyone who's interested had to be involved. You can't just grab someone who has done a 2-story building and ask them to construct a high-rise building. You can't just ask someone who has designed a 2-story building to come and design a high-rise building. Same time, the research side as well. Same time, you need the experts to really. So it's if you're not careful, we will. I don't want to say too much, but we could be having some failures. As I said, look at the web a few days back in Sydney. So the super tall buildings, and again the definition is about 300-meter height, and mega tall is 600 meters. In few years' time, we'll have more mega tall, 1 kilometer tall buildings in the future. There's one being built. Unfortunately, the one I was involved with, GFC got caught to the global financial crisis, did the foundations, and then stopped there. But it may come back again one day. But there's another one, very slow, but Kingdom Tower in Jeddah, which is going to be 1 kilometer, is being built at the moment. Anyway, see this one. First recognized skyscraper is 1885, is the 12th story Chicago home insurance building. And I remember in growing up in Colombo, the tallest building, we used to go to the Selinco Tower and say, this is the tallest building. And now, again, there could have been lift, I'm not sure. Going in the escalator was the we really enjoyed that, going in the escalator. But we had to pay, at that time, we had to pay for it, going in the escalator as well. But now it's free, I know. But, so it's, again, so goalposts have changed all the time. It will keep on changing. A tall building I had an archive from Melbourne. You need to say 2-story building in that was, I think, 1840s or so, considered they put like a tall building, 2 stories. So we can see how the goalposts have changed. So Burj Khalifa is really a structure which really changed a lot of things. And we were, in fact, again, privileged to meet some of them in Dubai a few weeks back. And then the Shanghai Tower, which is really, Shanghai Tower, second tallest building in the world, brought the new techniques, the computer parametric design, to really, certain things I'm going to say today, they try to bring it. It's twisted every story to really get the best out of the wind, and some new techniques have been found. These are the 3 buildings I like in the world the most, Jinmao Tower to the Shanghai Financial Center, and again the Shanghai Tower now comes here. So 630 meters tall, and it's twisted, and it's got some features. I was there when they topped up the concrete. Only thing is my friend as well. There was a project director. He the communication I had with him before was this one. I think is one of the tallest to pump concrete. You can't see these 506 meters. So that exercise. I was there when they were pumping to the top level. So it's really good to see all that. Now, again, because of the limited time, I will say this one now. The design has changed now. Those days, we had the material. We had the material supplier giving us the concrete and saying, yes, we try to pump this 500 meters. Now it's different. We are working what's called looking at the performance. What is required from the material, and we go and design the material. Now, in this case, we want to pump the concrete to 506 meters. That is the performance criteria. Then you work backwards and come up with the best mix. That's why we need people like even Mr. Ravini Shankar to say what are the chemical admixtures you need to. Pumpability is totally different. People are really mixing up pumpability with. I remember having very good conversations with Captain Korat in Melbourne once about when you talk building the Celestial Tower. I think it's really Sri Lanka has advanced so much as well. So in this case, other feature is there's a double facade. It's again becoming popular. Not just single layer of facade, double facades. So that due to thermal and many other reasons, easy to clean, and even aesthetically they think it's better. So there's a double facade in the, again, we had a big research project, double facades last 5-6 years at Melbourne Uni, sponsored by Perma Stilisa, the biggest company, the facade company. So I've just noted down, because the limited time, I don't want to take all the time. So I just summarize what are the areas that we have some progress, where it's heading the world. I'll show some slides later on, but wind engineering, aerodynamic shaping, and virtual wind tunnels. And that is somewhere we are going towards. World has changed last so many years. Fire engineering is a key. Now, that is the which is really restricting the height of the buildings at the moment, the fire engineering. And if you give it to Mr. Shomal, he'll design if you want 2-kilometer building. But the foundations and got the techniques to do things. But it's really the fire engineering which really would restrict that the height, the tallest height. So I'll give some comments later on. And earthquake engineering, higher mode defects are there in the, again, if there are any questions, I'm happy to answer, but the higher mode defects have to be considered. And the computers have allowed us now to really use performance-based design techniques. So it's really covering that. And so there are recent developments in that. Construction site, advanced formwork systems are coming. We want to also that's where I'm leading this center in Australia, the Modular Construction Center, and that's where the world is heading in next 10 years time. 10 years time, a lot of things will be prefabricated in the factory. So I'll say a few things there. And the vertical transportation systems have to be really some modifications. Advanced materials, we are, as I said, we are designing the materials, high performance, high strength, work on changing. We need to change the design codes, because this is totally different. The Australian code, which I have been involved last probably, I think I've become one of the most senior member now in the code committee. But it's really, I introduced high strength concrete to Australian code. At that time was only, I think I started with 65, and then we brought it to 100, and now we went to 120. Next revision, we are trying to go to 150 MPa concrete, and so then we need the composite materials. Let's, again, as I said, design the materials. We don't need to worry about whether it's concrete or steel or composites or nano materials. Just get the best out of the material. It can be a hybrid material that gives that best performance for the structure, rather than worrying about this is a concrete building, steel building, like that. So there are other issues as well, where again, I won't spend time now, we need to increase the lift travel. There was some discussion in Dubai this time, the conference. Let's go through very quickly some of the innovations, new formwork systems, Eureka, again, my involvement from the beginning as well. I'm not the one who innovated this system, but I was involved from the beginning. We had to make some adjustments for the design. It's jumped 2 stories. Before it was only jumped 1 story. Now, the first time, so it's now been practiced in other parts of the world, but this is the first in the world to really go into so really looking at the advanced formwork systems, modular construction, as I said, world will become prefabricated. Again, when we had a short course on modular a few days back in Colombo, but I said that as well. It's like the best engineered product in the world is like a plane, if you keep the rocket aside. What we are doing now, buildings, we are following that. It's a product base. In the future, it will be done in a factory, brought to the site, and put it in on site. So because to maintain the quality, and see the advantages of modular buildings. It's all prefabricated in a factory, normally fitted out in manufactured volumetric units, and then used to create varieties of apartment types, high-rise buildings, and the speedy construction. Construction speed is a key now for everything, as we know, and that really this modular brings that. Just one example, again, that I was very happy, very privileged to follow this from the beginning, the construction of this 44 levels, 206 apartments, and these are the modular units. These modular units were done in a factory, and I gave more details in that short course, but today will be just a summary. But the modules are like now designed. These modules are broken into modules, done in a factory. See, these are the modules. Weight is a key factor. Even the bathroom pod is done in the factory and then put in there. Advantages, there were rollers here, so there was some flexibility for the architects. They could change their mind and say, I want the bathroom here. So there were rollers here. So these sort of like new things are coming up. Very interesting. So again, I'm privileged to lead that the main center in Australia. I think it's probably the only one in the world, modular in academic institutions in modular side. So this is the Rato tower brought in the factory. They got special permission to do it at night because transportation is a key. And it'll be very quick video of that rather than trying to explain this technique. Hickory, the company, is very innovative, and they are helping in the center as well. So it's really very, very quick construction brought in the, just to save time, I will expedite a bit the video. It's very clean around the site, and it's done very quickly. And there was a next door building we started long time before traditional construction. This beat by so many months. So it's really this is picking up a lot, and this will be very quick. Again, a video of the time-lapse video. Be very quick of the construction, which really brought some innovations. Today, I will not talk all that, but bringing the shotcreting, just limiting the weight of the structure. So it's very carefully planned and less waste. Not much waste. It's a sustainable building because the all quality, highest quality, because done in a factory. Weather doesn't get affected in building things. and no disruption to traffic, or very much less disruption, and as I said, it's done mostly at night, and so and sometimes there's no interruption even on the people who are working in other places next door, and so this again that's a prediction I have made, and I think it will, in 10 years time, majority of the production will be done in a factory and brought into site around the world. So that's a major trend. As I said, we are doing a lot of development work at my center is doing lots of work in this area, and I'm happy to really to describe that if there are any questions. And so it's done very quickly. Even the facade was connected, fixed before in the factory before it was brought in. Prefabricated reinforcement. So this is really becoming prefabricated, and this is really actually Mr. Shomal told me Captain Kuratna used that in the Celestial site the first time. I think it could be the first time in Sri Lanka. So we used that. Again, it's already to say the Chinese builders didn't know. I remember myself and Mr. Shomal talking to them in Beijing, telling them you can save a lot of time and go for prefab reinforcement, and so I think they really adopted and they acknowledge that we help them to make it. Anyway, other ones I will go through very quickly. These are some of the things. Early 90s, I designed these columns, the composite columns, came up with a system to pump from bottom 4 stories up, and that building is one of the major buildings, immigration building in Melbourne. So these are the beginnings of all that, and still the composite columns, and at that time we didn't have all the technology. We were just wondering whether we can pump 4 stories up from the bottom. So somehow we did that, and I think it's really at that time. And other things are coming up. Again, very briefly I will say cranes, and of course have to be very carefully designed, because what happens is you design the structure, and then sometimes they want to join the crane at different locations. They change all the time. So you have to be very careful about that. Why I put this slide is the crane technology is changing. In few years' time, there won't be any crane drivers. And I don't know about Sri Lanka, but crane drivers earn more money sometimes than engineers. But because they have the height allowance, they have the risk allowance, all that. But what's happening now in the world will be to really remote control cranes will be there. So already it's come, that technology, mobile cranes and no operators. So it's really a safety is there as well as, so that's going to come in the crane technologies. Again, the latest developments in design, I will not spend time on this, but outrigger system, and then have been designed here. It's really a simple technique of, it's really 1 + 1 is more than 2. If you have one here, join up with another person, 1 + 1 is more than 2. It doesn't work with people sometimes, but at least in this structure it works very nicely. You join the core with another element, the outrigger columns, and that really brings that stiffness. So basic fundamental techniques. So again, the Eureka Tower is one of the first in the world to use outriggers, and again I was privileged to be working from the beginning, working with the architects from the day one. These are the outriggers in the Eureka Tower, and it's really the join in the core, and the architects use that really to divide the apartments even. So it was used architecture. That shows the importance of. That's another thing happening in the world is that integration. The building information modeling has facilitated that. That is the integration of the disciplines, architecture to the engineering disciplines together, the structural to mechanical to building services, all that together. So integration of that is a key from the beginning. And the improvements to concrete technology is close to my heart, this subject where, as a very, very young engineer, I was a foundation. Again, I consider him as my mentor in the technology. Ken Day was one of the best in the world. He designed the foundations, concrete for this, and he got me involved in that. as a young lecturer, we were doing some tests. So it's really even early days, 80 MPa concrete. This one, I was acknowledged last year, as I said, getting that award. I was acknowledged to first person in Australia to use high strength concrete in this particular building. I use 65 MPa as a young engineer. These are very proud moments for me. And then getting to the Burj Khalifa, which is really again the work R&D. That's really the for academic. The most proud moment is that if we can use our research and then used in the key buildings or key structures, that's our that'll be a very proud moment. Using my work in Burj Khalifa to design some of these columns, the confinement work I did for long time. I will not go through everything, but we are, as I said, 50 MPa. We are now Australia. We are using up to 150 MPa in commercial concretes, so that we are getting to this engineered very high strength concrete. Engineered the word. We need to engineer the concrete to get that all these properties. And then to again, I try to skip this slide, but we need to do a bit of work on the codes. We are still we need to really develop this 100 to 150 MPa range, codify them properly. We need to, because again there are students here, but it breaks through the aggregates. Aggregates are the weak link in when you have the in high strength concrete. It's not the normally it's a paste, which is really, it breaks through the paste. The weakest element is the around the aggregate, the paste. But when it gets to high strength concrete, it breaks through the aggregates, because aggregates are the weak link. So it's a totally different behaviors. And I know Kanishka, who is in the audience, is going to do a PhD with me. You're probably not 2 or 3. That's the kind of area you could be working on. So the stress strain models, high strength concrete is not always, you can't say just go and use high strength concrete. It's very brittle compared to other concrete. So you need to be very careful, that brittleness. So that's the stress on the y-axis, strain on the x-axis. See the high strength concrete, 80 to 100s, and become very brittle. We have explosive failure when we test them in the lab. So this is the work that I did, sort of pioneering work I did at that time, trying to reduce the, now few people have picked up and done research, but our work is very early work, trying to reduce the spacing here of the stirrups or ligatures, we call it, in between, so that you get extra confinement. And this is really 2001, this book. I started revising it a few times, and I can assure you now I've probably spent time revising that. It's probably one of the most very popular book, people deciding high strength concrete at that time. You talk about 2001. None of the codes covered high strength concrete at that time. And the latest developments in design, the wind engineering, I'll be very quickly running through these slides rather than detail. There are many new developments in wind engineering, wind tunnel techniques. Everything depends on how it's governed by the perception of motion, how you feel going to the top of a building, how you feel. It's like going in a boat. We know we don't want to go, we get the seasickness. So it's similar like that. Buildings are getting taller. When you get to the top of the building, we may get sick because of that type of phenomenon. So acceleration is a key, which really governs that. We need to do a bit of work. It's very crude to say acceleration. Now we need to go into another level and see, is it the acceleration? There are other effects as well affecting that perception of motion. But up to now, we just got some charts. We just said, yes, acceleration, limit the acceleration, yes, done. But now I think in the world, we need to do a bit more work. Is it the acceleration? I'm working with one Professor Kenny Cock in Sydney University, who was one of the pioneers in this work, and trying to really see whether are there other parameters. There are behavioral parameters. That's why we need to do some multidisciplinary work now, because of we have to work with the psychologists. There's no point just engineers doing this work. That's why I think places like Open University are very important, because you get a mixture of different, many other disciplines. So we need to, that brings everyone together in a team. And again, so all that. I'll skip some of that. We need to learn from the Formula One. No, I followed Formula One from the beginning. It's really, from that to the planes. Planes are as I said, the best engineered structures. Why can't we learn that from all that, what they have done, all is to, and apply to the buildings. That's what we are trying to do that in the world. And we will see more and more. Shanghai Tower is a good example. And the wind tunnel techniques, and I'll skip that. Once it's become a tall building, there's a crosswind component really dominates sometimes. It's not the long wind parallel to the structure, like moving parallel to the wind. It's the crosswind, like which is not in a low-rise building. So it's the perpendicular to the wind, which is really vibrating the structure due to vortices and all that. I will not go into fundamentals today, but it's very important to understand the fundamentals here. So it's a totally different game when you're designing a tall building. So I'll skip the allowable values. There's a paper in the web. If you download tall buildings, wind, and my name, you'll see a paper. I heard that, I don't believe all that, but it's supposed to be broken many records of downloaded, the highest downloaded paper or something in our field. But the horizontal acceleration on the y-axis, the frequency on the x-axis, with the flow over a building model, is really compression dynamics. That's compression fluid dynamics. The computers have given us this power. When I started my career, my hard disk was only 50 megabytes as a lecturer. Now what is that? 50 megabytes. I think I have a 50 gigabyte USB here. So it's really like things have changed. Why not use the computational power now? It's really to really take it to another level. That's coming from here, Capital Twin Peaks wind tunnel model, which was done in Australia. And again, that's the CFD model developed by CSEC under the guidance of Mr. Shroman. So that comparison, so here been some pioneering work have been done here. These comparisons, I don't think many have done that, comparisons of real wind tunnel to real CFDs and all that, not too much. So this is the Lotus Tower work. Again, that from the beginning, from day one, my involvement with Mr. Jamal also with the Lotus Tower. This work have been done in the China. We visited the wind tunnel. We got the comparisons. This is the work we have done. And there's a video. No, I will not spend time running the behavior. So really, we have got the techniques now. So when we compare, it's not too bad. The CFD gave results which are wind tunnels. So now we can go into virtual wind tunnels and all sorts of things. Again, I had 2 PhD students working on it as well. MAST was a challenge to work on the fatigue, to many things in the Lotus Tower. There were, but most pioneering work in the this is 1 kilometer tower, Dubai. As I said, I will not spend time. And the other thing which really becoming more important in the world is that the pedestrian comfort. And we are building so many buildings. It's like wind tunnels now. Those days we had only 1 or 2 here and there buildings. Now that every street is becoming like a wind tunnel. There are so many high-rises coming up and we can't even walk. It's happening around the world. It's not yet in Colombo, but it's really pedestrian comfort. We need to do a lot more research as well. So it's really very early stages. What are the allowable values? There are some crude documents. I think today I didn't spend time. Even we have developed a document for pedestrian comfort. But no, let's say wind speed has to be less than that, then you are okay. It's not true. We need to do more R&D work on that. What is the allowable criteria? We had to get that behavioral side, the social side. We had to bring the psychologists. We had to bring all of them in one team working on these issues, not just engineers and architects and so on. So anyway, I'll skip the dampers. That's another one. World is becoming the taller and taller. We need to look at the dynamics. That's the one, Taipei 101, very smartly they have got this observation tower. It's obvious that in dynamics, go and put something, right? So you put a very big weight on top of something, it will reduce the dynamics. So these are obvious things. Getting back to fundamentals, to common sense things. So here the big mass on top. So in here, it's been used as observation deck as well in this, very smartly used. So we are moving into that. Wind, one comment that we want to make is, if you want to design a structure in wind, what we have learned is that confuse the wind. Don't allow the wind to dominate. Just go and put some different ways of doing it. This is a Kingdom Tower Burj Khalifa, they did that as well, and Shanghai Tower, and some of the structures here also, just like confuse the wind. And then here and there, if you build a basic principles, if you bring a very smooth tower, then the dynamics will be like, no, it's not the best. But so we need to look at that aerodynamic shaping. This is what we planned for the 1 kilometer tower. Unfortunately, didn't work. All the work was done at Melbourne University, planning that the virtual wind tunnel work, CFD, and it's just the we try to put some slots to reduce the wind. So we need to be smart. This is really one of the world first, I have to say, that in what's happening in Sri Lanka, where the monitoring, that's the area that again will progress a lot. The wind monitoring, and also the buildings have to be monitored. That's why I'm here as well, sometimes here, because I'm very privileged here that we can go and monitor buildings. We don't have that option in other countries now. There are other issues, OHS issues. There are the construction managers don't want them to come. In this case, I think Captain has allowed Shiramal to put these anemometers on top of at that time, the Celestial Tower. So it's really one of the world first, where I can now, through my mobile phone, I can click from Melbourne, I can click and see what's the wind speed on top of the Celestial Tower. So it's really a huge achievement for Sri Lanka. I haven't seen that in other countries doing that. So we have some world first here. So anyway, the new develops in engineering, extreme events, that's where I spend a lot of time. I'll be very quick. Fire engineering, as I said, is limiting the heights of the buildings. All sort of fires were there. We know the Grenfell Tower fire, the facade fire, and so we have started thinking about the World Trade Center changed a lot of things, brought the refuge flows. Again, if there are questions, I will explain. But then the elevators are now, those days when we were growing up, what we were told was, if there's a fire, don't use elevators, right? Keep away from that. But now it's the other way around. We can, because these pressurized shafts, the pressurized lifts have changed the world. So it'll keep on changing. Why I'm presenting all this is to say, this is not the end of it. Next 10 years, 20 years, 30, all these things will have to be developed further and further. We still don't have all the answers. So even pressurizing the lifts is not perfect. Sometimes the smoke comes, even that. So, so in here the modeling, that's a key model that we have used. Again, I won't spend time. Now we are using the furniture. We can model, because of the computers, we can use the real furniture in a building to really come up with the best plan. Before, what we were doing was go for the extreme. So it's a really over-designed. It's not economical. Now we can use the real furniture to really see what's the performance required. If there's a fire, what do you require from this building to really have that fire resistance? Go into the computers, use the computer power. This is what happened in after the World Trade Center, especially. Those days, we had to use the staircases, both firefighters, and see the destruction here. Firefighters had to really, couldn't do much. They had to really wait for the people to come. Now it's changed. And that this work, which very brief, I will be very brief, egress, how to escape from the building, and the building performance, and the fire protection engineering. It's a big area where the Innovative Fire Engineering Group, led by Dr. Kate Nguyen, has done lots of work in this area. And the Lotus Tower, it's really one of the first where we did the modeling. Again, I have to acknowledge the whole Lotus Tower team, including the PC unit at Morato University, led by Professor Manavadu, for really allowing us to do this work. And the Lotus Tower is one of the first. We did the modeling, and we managed to make some design changes at that time. So it's really one of again, I haven't heard other buildings like that, day one using the modeling. So that's the kind of modeling we did, really to evacuation modeling at that time. What happens if there's a fire? People start escaping, and like that. So again, we are very proud of that type of modeling done for the Lotus Tower. This is really a key one, the fire performance facade. What happened in Australia and other countries is, we know the aluminium composite ACPs. Really, they are like, there are ACPs here in Colombo as well, some of the facades. So they are like, anyone can go and light it. And this is the thing. I'm sure it's not going to happen, but so it's really, it's a security thing as well. this is something the world first we did, having an 18-meter test. We are trying to use some vertical fire breaks. Now, all the facades, there are 5,000 buildings in Melbourne, facades had to be replaced because they are very strict on this ACP. So, this test was done to show that you don't need to take the whole facade out, have some vertical breaks. So, just replace that and then change the vulnerable ACPs, and then so that the fire won't spread to the next level. So, this is a real test done there, and that's a thermal. We did some very, very good work of. So, anyway, I will not take time to show that modeling. Computers have really given us the opportunity, bringing the virtual reality and VRs and then all that to really bringing with the computers power to model a blast here. It takes a bit of time to load it and all that, so I won't show. There's a blast here, this will get blasted, and then this was in the TV in Australia once. So, this progressive collapse, what happens if one slab falls on the other one? Lots of dynamics as well. Again, this is the world first the modeling a full building in every element was modeled, and to really, this is a government structure in Brisbane. So, see these columns, we have real structures like that. If you, again I won't take time because of the limited time I have to show this one. It takes a bit of time to load it and you will see the building falling. We just took a column out and you can see the building will fall. So, it's really something modeling has allowed us to really get into that level. Future materials, we need to, there will be super alloys will come to the high-rise scene. Does not, we can't just say just the cement, concrete and steel and all that. Nanomaterials, we can't avoid the nanomaterials. And we were talking about the other day the graphene. The Sri Lanka is privileged to have the vein graphite here, only country in the world having that, the purest graphite. So, we can use that to our advantage. Actually, it is told in conferences. Sri Lanka is we know we were famous for tea those days, but now it's really we will be one day becoming the best graphite in the world. No, graphene in the world. No, so really we can. Only problem now is this. All these graphite companies are controlled by the multinationals. They will just take if you're not careful, they just go and take the graphite and go. And they are very smart. They've already done that, I think. But anyway, bio-inspired materials, learning from the nature, that's the key, which I've done a bit of work on that. Maybe I'll explain that if you have any questions. We've done a bit of work also on the oxatic materials. That is, we know that those students who have done the materials fundamentals, if you have if you press something, it will dilate. It will diverge, dilate, expand, all that. Oxatic materials are when you press, it contracts. So, we can really use it. There's a truss type of technology being used, and if you see some of our papers, you see that we are one of the first to get into the oxatic materials then. And then we can use those advantages to really to look at the materials, and so we will be seeing more and more. Also, the recycled materials will come, and the municipal waste. We have started been using municipal waste to produce some cementitious products. We started that work. That is going to be next 10 years. We see the recycled materials rather than dumping. Colombo also has a big problem. And then maybe that the Colombo, the waste dump could become a gold mine one day if it's can be converted into recycled materials, can be used in construction. That's a bit of a very early stages. I got a project on biomass. Again, I will not spend time. If there are questions, I'm happy to explain. I just gave a talk, you'll see in the web on the engineered cementitious materials, keynote in Keynes, how to use biochar in concrete. So like that, there are new materials will evolve and come to the construction industry. Tall buildings are really, as I said, there won't be any questions asked. People will be asking the question, why not a tall building? So we have to really use all this, our knowledge. It's a specialist area, and it will keep going. And it's really, again, there are some number of people here helped at the beginning for me to come up with the Green Building Council of Sri Lanka in 2009, and it's really the selected group. Again, it's all right to acknowledge Shiromali, who gave me a list of, I didn't know many people, just gave me the list to start the Green Building Council of Sri Lanka. We invited 2009 Golface, famous meeting in Golface, brought the Green Building Council of Sri Lanka, and we are part of the World Green Building Council. That has changed actually, even people are asking the question now, sustainability. Why not sustainability? And so that's the key one as well now. Sustainability will come. So future buildings, just to finish off, so the challenge for the engineers and architects also and contractors, everyone will increase in the future. And it's again, new generation buildings will be taller, lighter, and more slender and sustainable. So these keywords, even the clients are now asking the question. Slimmer, sustainable buildings have greater commercial value. Actually, to rent a building in Australia now, you have to have a certain green rating. Otherwise, you can't rent a building. So clients have started asking. They ask the question now, what is the Green Star rating in Australia now? Same way I know Sri Lanka is transforming as well. There are questions, the Green Building Council ratings, people will ask question. So supercomputers have given more opportunities for optimization, a key word for the future, optimization. Artificial intelligence, it will come in a big way. Machine learning, which is really, some of you could be doing research on machine learning. We train the machines. See, the best machine learning came from the smartphone, our iPhones at that time. I don't think Steve Jobs used the word machine learning, but that was his vision, to really make it the smartphone at that time. And there are other issues like fractal geometry, which is really repeating things to all that. Other one is the evolutionary optimization. This sort of techniques will come to really tall buildings, and I know some work done in Colombo as well on those things. So this is a real one, which really we were asked to, like it didn't come through, but we were asked to look at this one. And the idea we came up with at that time was use steel plates, thin steel plates filled with concrete. So it's a real, architects had a vision to do that. Unfortunately, they couldn't find the money, I think, to do that. But anyway, it's really, it stands out as a key one, which we did bit of work trying to really have some innovation, bring into a structure in tall buildings. So those things will continue, and I can talk for hours and so on. But as I said, I teach for 12 weeks a full high-rise course. So, but today was just very much a summary where we are heading in the world, in the high-rise scene. And again, as I said, Sri Lanka has done very well, and we are not behind compared to other countries when it comes to high-rise structures. I'll stop there.